The problem that's posed here is to find the slope of the line between the points A, f of A, and B, f of B. Now that problem's just posed without any of this other stuff. You might think about how to do that before we go on without trying to read everything else. But we're trying to find the slope between these 2 points. Well, most people in the class did pretty well with this one. I simply said, well, the run goes from A to B, that's going to be B minus A. The rise goes from f of A to f of B, that's f of B minus f of A. Locating the points A and B on the x-axis and f of A and f of B on the y-axis, we easily see that these are the rise and the run, so the slope's going to be f of B minus f of A over B minus A. That's summarized by simply saying slope is rise over run is f of B minus f of A over B minus A. And that was the answer to the question. Now, in looking at what people did in class, I found that some people had a kind of a bad idea about what to do next. Now really there's nothing to do next. You can't simplify this until you know something about the function f. But that didn't stop some people from making attempts, and that gave us plenty of stuff to talk about as far as bad ideas go. Okay, so let's look at the first bad idea. The first bad idea is to say that, sorry, I had my hand there. First bad idea is to say that f of B minus f of A equals f of B minus A. Now that's a real bad idea. Now it's an easy idea to come up with. I admit to having made that mistake a couple times in my early days. This looks like a distributive law situation where you can factor out the f. And it's clearly, but function notation does not indicate multiplication, so it looks like a distributive law situation, but it's not. Let's take an example. F of x equals the square root of x, just so we see why this doesn't work. Okay, well f of 25 minus f of 16, if this is true, should equal f of 25 minus 16. But of course f of 25, f of x is the square root of x, the square root of 25 is 5, f of 16 would be square root of 16 or 4. Excuse me. And 25 minus 16 is 9, the square root is 3. And it's certainly not true that 5 minus 4 equals 3. It turns out that the only way this would be true in general for a function is if the function was linear. As a matter of fact, this is a statement of the condition of linearity for a function. So this is a real bad idea. Don't treat function notation like a multiplication. Don't think you can use a distributive law and factor things out. Okay, another bad idea. This is an even worse idea. Okay? And we all keep a sense of humor about these because we've all made these mistakes. This isn't trying to slam anybody for having made the mistake by any means. Okay? It's a very easy mistake to make if you're not thinking about the laws that you're applying. That's why we need to think about the laws. So here's an even worse idea. F of B minus f of A over B minus A is f of B over B minus f of A over A. Okay? Now there are a whole bunch of things wrong with this, like what happened to the negative sign in the A. We just absorb it in here. What happens if we reverse B and A? Okay, what if we have negative A plus B? Then do we have f of B over negative A minus f of A over B, negative B, whichever? Okay? That just doesn't make a lot of sense that would be true. And of course here's a numerical example. If f of B is 8 and f of A is 6, and B is 4 and A is 3, then if this is true, then 8 minus 6 over 4 minus 3 has to be 8 over 4 minus 6 over 3. 8 over 4 is 2, 6 over 3 is 2, so 2 minus 2 is 0. But clearly 8 minus 6 is 2 and 4 minus 3 is 1, and we get 2, not 0. So we see that there's something seriously wrong with that idea. So we need to be careful.